Let's talk about what it means to have a state function versus a path function. Oftentimes, we hear that a state function does not depend on the path taken, and we typically see a picture that's similar to this, where we say this blue arrow here is representative of a state function that is independent of a path, as we see here in red, which is the path function. But for some of us, this picture or this analogy doesn't make sense. So let's begin with an example formula. Delta U equals to Q plus W. This is a thermodynamic formula. So a state function is something that is quite literally final minus initial. So with this equation, we would say that delta U, U final minus U initial, is a state function because it is only affected by the final value and the initial value, hence the delta U. And so this is what we call a state function. On the other hand, the heat and the work are path functions because different combinations of these two can lead to the same change in internal energy, depending on the specific process used. So the way a system moves from state 1, the U initial, to state 2, U final, can happen through many different processes or paths or combinations of our two variables here, Q and W. And so that's what makes this a state function and these two path functions, because you can have different paths that you can take, or a higher Q and a lower W, or a higher W and a lower Q. These are different combinations or different paths.